It seems the universe, at this deep level, behaves differently when it knows it's being watched. Section 6. Key difference: wave-particle duality, an identity crisis. Classically, we like to keep things neat. Stuff is either a particle or it's a wave. A baseball is a particle, a solid, localized lump of matter. Sound or light, in the classical view, are waves. They spread out and carry energy. They have very different characteristics. Particles have definite positions, while waves are spread out and can interfere with each other, creating patterns like ripples. Quantum mechanics pretty much tosses that neat distinction out the window with something called wave-particle duality. Everything at the quantum scale, electrons, photons, even whole atoms, can act like both a wave and a particle, depending on how you set up your experiment to look at them. Light, for example, can behave like a wave, creating interference patterns just like ripples in a pond. But it also acts like a stream of tiny, discrete particles called photons, which is what Einstein showed with the photoelectric effect. An electron, which we usually think of as a tiny speck, can also behave like a wave, diffracting and interfering with itself. It's as if that baseball we talked about can sometimes act like a solid object and other times spread out like a ripple, all depending on what you're trying to measure. This dual nature is one of the most counterintuitive, yet absolutely experimentally verified parts of the quantum world. Is your mind officially blown yet? We're really getting into the nuts and bolts of how reality itself operates, and it's definitely a wild ride.